Hello. Here I'm going to demonstrate the new multi-agent scenario that we developed after the live demonstration in class. So we're going to have four different vehicles and their goals are defined here. So here we're starting at the left, bottom, right, and top positions respectively. And their goal position is defined similarly. And this just means that this last car will have two time steps earlier than the other vehicles. Um, so now I'm going to run this. And first of all, you can see that each path is calculated around 0.1 seconds. You can see the relative cost of their paths. And here I have it so the same scenario will be playing every 20 seconds. So it's just the same single path generated for each vehicle repeated. So let's break down the path that these vehicles generated. So we can see that the blue cars, first of all, are obstacles, predefined paths that each of the other cars have access to. And then the yellow cars are the multi-agent. Each of them are a single agent that has access to the blue cars paths, but also has access to other yellow cars paths based on what order they are in the prioritized planning. So we see here that this car, first of all, is lagging behind because it knows it just has to be behind this blue car, and it doesn't really care where in the lane it is unless it needs to move right after this vehicle. So let's see what happens here. This car just crossed intersection because it knew that this car was pre-programmed to stop there, so it knew it had enough time to cross the intersection. Meanwhile, this car only took this long to get to this intersection, even though it got, it could have gone to this point earlier, but it did not need to, because it would only be able to make a move at this point. So although it's not realistic in a realistic scenario, it's still optimal in terms of our cost function, which could be something to look at if we wanted it to be different, to be more realistic, so it doesn't stop in the middle of the street like that. But it does get by and find itself behind that other car, and it's able to cross intersection without even the other car needing to stop. So each car finds the optimal path without collisions, but also in the best way to optimize for time based on their priority.